difference is that yesterday we didn't have a constant term whatsoever. They just had a blank space there. We were trying to figure out what the constant term was. Well, now we're dealing with an equation, so they're not just going to have a blank space there. So if there are any constant terms, you got to move them to the other side. Your variables need to be on one side, both the squared and the linear, and then your constant terms need to be on the other side. Once you do that, then you're going to complete the square like we did yesterday. But when you complete the square and you add it to the left side or whatever side your variables are on, you have to add it to the other side because we've got to keep our equation balanced. Okay? Then we're going to factor and we're going to solve by taking square root. So let's look at an example of actually doing this. Let's look at number 17. Okay, we've got a squared minus 16a minus 53 is equal to 0. Okay, a squared minus 16a minus 53 is equal to 0. So we want to leave our variables where they're at, on the left side, and we want to move that 53 to the other side. So we need to add it to both sides. Now, when you do this, leave a space where the 53 was because we're going to complete the square there. So we need a space to put that number. So don't move your equal sign over like you normally do to fill the gaps in an equation. All right. Now we're going to go over to the side. We're going to complete the square. Negative 16 divided by 2 is negative 8. Negative 8 squared is 64. So we add 64 to both sides. Because we can't just introduce this 64 to the left side and that be it, because then we've changed our equation. But if we add it to the right side as well, we can take it back, we can take it away from both sides, and we've got just what we started with, so it's not a problem. Okay, now we've created our perfect square trinomial on the left side, so we can factor it. A minus 8 squared is equal to, let's see here, was that 117? 54 plus 64, 117. Okay. Because that entire left side is now squared, we can take the square root of both sides. Okay, taking the square root of something that's squared leaves you with just what was squared, a minus 8. When you take the square root, do not forget to put a plus or minus in front of that square root. Now, I'm going to check really quickly. I don't think 117 simplifies, but I'm going to check really quickly and see if it's divisible by any of my perfect squares. 4, 9, oh, it is, 9. Okay, 9 times 13, so that means we've got the square root of 9 is 3. So the 3 comes out of the square root, the 13 stays under the square root. We're not quite finished yet, because our variable is not by itself. So we've got to move that 8 to the other side by adding. Now be careful with this. We cannot combine that with that square root because the 8 doesn't have a square root on it. We can't change any of those numbers. So we just put that 8 in front of the plus or minus 3 square roots of 13. We cannot combine it with either of those numbers. Okay? We can't do 8 plus 3. Okay? Do not say that that's 11 square roots of 13 and 5 square roots of 13. Okay? It's not the same. Multiplication comes before addition and subtraction. You would have to actually multiply out the 3 times the square root of 13 before you could combine them with the 8 by adding or subtracting. Okay, so these answers are going to look pretty similar to the answers that we got from the quadratic formula. But one of the nice things about completing the square is it takes kind of a step out of the simplifying because you don't have the denominator to worry about there. You're not going to have quite as much simplifying to worry about in the end. Okay, so it's a few more steps in the process, but I don't know. It's kind of a toss-up. Sometimes completing the square is easier, sometimes quadratic formula is easier. It just depends kind of on personal preference. But We are going to have to use completing the square later on for something else, so you do kind of need to know how to use it. Let's look at number 18 as well, just so we can make sure everybody's got this before we practice it a little bit. Okay, number 18 is k squared minus 18k minus 94 is equal to negative 9. So we've got to move that constant of 94 to the other side. This time there was already a constant over there, so we're just going to combine those terms. So 94 minus 9 is 85. Okay, let's come over to the side, complete the square. Negative 18 divided by 2 is negative 9. Negative 9 squared is 81. So we add 81 to both sides. And we factor. K minus 9 squared is equal to 166. Take the square root of both sides. K minus 9 is equal to the plus or minus square root of 166. Let's see if 166 simplifies. I don't think it's 16. How about 9? Nope, not going to be 9. 4? Nope. No, it's not 25. 4, 9, 16, 25, 36. Nope. Not looking like this one's going to simplify. And that's okay. Not all of them do. Okay? So it doesn't simplify, so all I need to do is get my variable by itself. K equals 9 plus or minus the square root of 166. Okay. There was something I was going to, oh yeah. I didn't do an example like this. Both of our examples ended up being minuses right here inside of our factor. But if that were a plus 9 and I had to subtract it from both sides, then this, in my final answer, it would be negative 9 plus or minus the square root. Okay, I think that makes sense, but I just wanted to say it because I had a feeling I would answer that question about 10 times when one of those comes up. Okay, so if you have to subtract it, then it just becomes negative.